This is ELC131, Circuit Analysis 1, and this video is on power. Power is the rate of consuming energy. Power, symbolized with the letter P, is measured in watts. The unit symbol is the capital letter W. Mathematically, power equals voltage times current. 1 watt of power is dissipated when 1 volt of potential difference exists across an element or device and 1 amp of current flows through that element or device. Now, the fundamental power formula can be rearranged as I equals P over V and V equals P over I. Now, over the decades, I've heard engineers and technicians refer to Ohms Law. The unit of measure is named after James Watt. There is no such thing as Ohms Law. James Watt made improvements to the Newcomen steam engine in the 1800s, and the unit of measure for power was named after James Watt. Unlike Ohm and Kirchhoff, James Watt did not formulate a law regarding power dissipation. Power is merely the rate of consuming energy. The equation that describes power is P equals E over T. Power equals energy over time. From our definition of voltage, V equals E over Q, we get E equals V times Q. And from the definition of current, I equals Q over T, we can express this as T equals Q over I. And if we substitute these in our fundamental equation for power, we end up with power equals V times I. Let's look at some examples. 120 volts is applied to an incandescent lamp and 833 milliamps of current flows through the lamp. How much power is dissipated in the lamp? As with our Ohm's Law problems, we always start by writing down the formula that we will use to solve the problem. P equals V times I. We substitute the given quantities. P equals 120 volts times 833 milliamps and solve for P equals 100 watts. Now, as with our Ohm's Law problems, we must have the unit symbol W after the numeric value in order to have a correct answer. Let's look at another example. How much current is supplied to a 500 watt heating element with an applied voltage of 120 volts? Again, we start by writing the equation or expression we'll use, I equals P over V. Substitute in our given quantities, I equals 500 watts divided by 120 volts. And solve for I equals 4.17 amps. Let's look at another example. 12.5 amps of current flows through a 1.5 kilowatt heating element. How much voltage is dropped across the heating element? The equation we'll use is V equals P over I. Substituting our given quantities, V equals 1.5 kilowatts divided by 12.5 amps, and solve for V equals 120 volts. Now, there will be instances when you're required to calculate the power dissipated and you're given I and R. Our fundamental equation for power is P equals V times I. However, we can substitute for V from Ohm's law that V equals I times R, and end up with this equation, P equals I squared times R. Let's look at an example. 200 milliamps of current flows through a 510 ohm resistor. How much power is dissipated in the resistor? The equation is P equals I squared times R. P equals 200 milliamps squared times 510 ohms. The power dissipated is 20.4 watts. There will be times when you are given V and R and you need to calculate the power dissipation. Again, our fundamental equation is P equals V times I. But if we substitute for I from Ohm's law, I equals V over R, we yield this equation, P equals V squared over R. So if 12 volts is dropped across a 1.2 k ohm resistor, how much power is dissipated in the resistor? Our equation is P equals V squared over R. P equals 12 volts squared divided by 1.2 k ohms. The power dissipation is 120 milliwatts. So the formulas that you will need to know to calculate power and or voltage and current are P equals V times I, V equals P over I equals P over V, P equals I squared times R, and P equals V squared divided by R.